Alright, domain, range, maximum, minimums. Okay, so I can't remember whether we already talked about this or not. Domain are the x values you can be. Okay, range is the y values you can be. And I'm pretty sure you know what maximum and minimums mean, but there are these things called local maximums, global maximums, local minimums, and global minimums. Okay, so local means just in that area. Okay, so if you think about, are you a local, it means do you live in this area. Okay, so it's just in that area. For global, okay, it's over the whole graph. Alright, so when it's asking you for the local maximum in an area, it says just in this little bit of area here, what is the biggest point in that area? That's your local maximum. For your global maximum, it's asking you what is the maximum of that function anywhere. Alright, anywhere within my domain. Okay, so we're starting to look at graphs now a little bit differently. Okay, we're starting to look at them and starting to restrict where they actually can be. Okay, so instead of just having a graph with never-ending arrows on it like we have been, like all of these ones here, alright, never-ending arrows, we're now going to restrict them. We're going to say that you can only be between these points. And the way we do that is with this ridiculous thing called function notation. Okay, now I know you guys all love function notation, but it's not as hard as it looks. -4. So this is the function notation example in your book.
Is this question 2?
No, this is just an example. So this is on page 144 in mine. Alright, so that's what the function notation looks like. Now this is really not that hard. It's not as hard as you think. Alright, it looks a lot scarier than it is. Here's your rule. Okay, that's it. That's your rule. Okay, that's what you're going to graph. You're going to graph x minus 1, x plus 2, x plus 4. Okay, this bit here tells you you're only allowed to graph that between x being -4 and x being 1. Okay, now I'm saying it equals 4, -4 and 1 because these brackets are square. Okay, if these brackets were round, you would not include those points. So it goes back to, what, year 7, where that means inclusive and this means not inclusive. Alright, you may not remember it, but now's the time to try. Alright, now's the time to remind yourself. Square brackets mean you include them, round brackets mean you don't. Okay, so at this point here, we are graphing this equation between x is -4 and x is 1. Alright, and then you've got this little guy here, okay, which is really of no consequence. Okay, it is called the codomain. Okay, so it goes along with the domain, it's a partner to the domain, but it's more about what y values it can be. And most of the time you'll find that that is r. So it can be any value, any number at all. Okay, so let's actually graph this equation. What is it going to look like? Okay, so again, I start with the basic graph. What am I looking at here? What's this graph going to be? It's a cubic. Where's it going to cross and where's it going to touch? What's it going to do? Tell me the basics.
It's going to cross 1 minus 2 minus 4.
Okay, so it's going to, that's a terrible little graph down in the corner there. So it's going to cross at -4, -2 and 1. Is it going to go, it's a positive, so it's going to do this, isn't it? So it's going to go, Alright, that's my basic graph. Yeah? Now let's start restricting it. Okay, I'm only allowed to draw it between -4 and 1. So when I draw this graph, okay, -4 and 1, it's still going to look exactly the same. But I'm not allowed to go past this way, and I'm not allowed to go past this way. So when I graph it,
You're just stopping red.
Yep, I've got to go like that. Okay?
That's easy.
Now, what... Yeah, no, that's fine. All right. All right. So you're just restricting the x values, okay, and stopping it where it says to stop it. Now there is something else I probably should have done there, and that is put a dot there and a dot there, okay. Because they're included, I put a closed dot. So if it's these guys, you put a closed dot. If it's these guys, you put an open dot. Okay, so don't forget that. If one of those brackets was round, I would have to put an open dot on whichever end of that equation, or whichever end of that graph it was. So in the last section we talked about restricting the domain, and we talked about function notation. So a lot of these questions are going to ask you for maximum, minimums, or even the range of that function. So to work it out, okay, it's all just done on your calculator. So if we have a function that looks like this, okay, whatever that function may be, it's very similar to the one we did on the last page, right? Then we can find a local maximum here, a local minimum here, a global minimum here, and a global maximum there. So therefore we can say the range is actually between this point and this point here. Okay, so we can actually put out the range by substituting these x values, right, our restrictions for this particular graph into our calculator, into our equation, sorry. So we substitute this x value into our calculator, we get this one. Substitute this x value, we get this one. And that's our range, because we can see they are where the global maximum minimums are. Okay. There are some graphs that may do that a bit differently. So for example, we may have something like this. Okay, as an example, we may have something like that, where our domain is restricted from here to here. Okay, but our range is actually from here to here. So substituting those values in isn't going to help us. So we need to find some other way of finding these x values to substitute in, which may be from the cubic stuff that we've done, or it may be any other way. Okay, but basically it's finding the global maximum and the global minimum, and then using those to tell me the range. Okay, that's what the maximums and minimums are all about.